Hello to everyone who is just rolling in now. We are so glad you can make it. Welcome to the live study session by Chegg. I'm Allison. I have my I'm currently taking my bachelor's degree at the University of Louisville. I'm studying chemical engineering. I've had lots of tutoring practice before. In high school, I tutored in organic chemistry. And then in college, I've tutored in calculus. And then I've been a TA for nursing chemistry and regular chemistry for about a year, where I hold help sessions at my college. For those of you who are new to Chegg, they are here to make your academic journey so much easier. And stoichiometry is really hard, but hopefully with these sessions, it will help you a lot. I've provided a few questions for us to start with. They're going to start off easy and get a little bit harder. I'm going to show you my preferred method for doing stoichiometry. I think it's the easiest way, but you can obviously change this to whatever method you prefer. But our first question is, how many grams are in 10 kilograms? We're going to answer this, but while we answer it, I encourage you to ask your own questions, any homework help you need, or just any questions in general. That's what I'm here for, so please ask those questions. So we're starting out with how many grams are in 10 kilograms. So we start out with 10 kilograms. We always find what we're looking for first. Right here, we have 10 kilograms, so that's what we start with. And we're looking for how many grams are there. So we're starting off at kilograms and we're converting to grams. So I do what's called a factor label method. So I start with my 10. It kind of looks like a train track is what I was taught, but we want to put whatever's on the top on the bottom. So in this case, kilograms is on the top. We have to match up our units, so kilograms goes on the bottom. And this is just a little math rule that whatever is on the top always cancels out with what's on the bottom. And we want to get to grams, so we put grams on the top. Now we need a conversion from grams to kilograms. Most chemistry classes are going to require you to memorize that conversion factor. So I know there are 1,000 grams in 1 kilogram. Good job. If you got that, good job. So there are 1,000 grams in 1 kilogram, and we are going to cancel out our kilograms because they're on the top and the bottom. We always multiply the top and divide the bottom. That's the rule with this factor label method. You can obviously, again, do it however you want, but this is what I find the easiest. So from this, I know that I'm going to do 10 times 1,000, since those are both in the top. And if you have a calculator, feel free to solve that with me and submit your answer in the chat, and we'll all get that answer together. If you know it, put it in the chat. Okay, 3, 2, 1. The answer is 10,000 grams. 10,000 grams. So we got a question from YouTube. Do we always convert to moles every single time? We do not always convert to moles every single time. It depends if the question's asking for moles. If it's asking for molecules, we can do a problem like that later, or if you have a specific example of a problem like that, definitely put it in the chat and we'll work through that. We only use moles if we're going from grams to molecules, or moles is one of our start or finishing things. So we don't always convert to moles. Most of these that I have tonight do not use moles. So if you have a question about moles, definitely put it in the chat for us. And the calculators are a very big part of stoichiometry, so definitely get a good calculator. All right, now we're going to move on in how many meters are in 7,841 centimeters. So again, like before, I start with my 7,841 centimeters. That's what I'm putting at the top. And then since it's at the top, again, it has to go to the bottom so it can cancel out. And then on the top, I'm looking for what do I need to convert to? And here I need to convert to meters, so I'm going to put meters on the top. Now, if you know the conversion from meters to centimeters, put it in the chat. That's, again, something really important you need to know and memorize. So I know that 1 meter has 100 centimeters. So again, we multiply the top and divide the bottom. So for this, we're going to do 7,841 divided by 100. So I'm going to give y'all a couple seconds to put that in your calculator, put the answer, type it if you know it. 3, 2, 1. We got 78.41 meters. And that is our final answer, 78.41 meters. So we got a question, what really are moles? Moles, it's from YouTube. Moles are a good question. They are a count in chemistry. It's very chemistry specific. It kind of tells you it's a count that converts from molecules to moles, and that number is Avogadro's number. It's a very important thing. The only way we can get from grams to molecules, the only way to get to molecules in chemistry is to use Avogadro's number. And Avogadro's number tells us how many molecules are in a mole. If you know that number, put it in the chat. That's another very important number. So does anyone know the number? It's going to be 6.02 times 10 to the 23rd. To answer your question, what really are moles? It's a count in chemistry used to get you from anything to molecules. So it's not really anything too specific. You're not going to see this in many other sciences. It's just to get you to that molecules number, which is very important. So we said someone thought that meters to centimeters on YouTube was 1,000. It's 100 millimeters. Milli means 1,000. Milli is the small 1,000. Kilo is the large 1,000. Now we're going to go on to our next question. And remember, if you have any questions, please put them in the chat. That's what I'm here for, is to answer your all's questions. So this one is a little bit more complex. It's a two-step conversion. So we started off with some easier conversions, and these are going to be a little bit more difficult. It's 2 steps. So we start out with what we're given. We are given 580,000 milliliters. So I write that. And then I need to know, what am I getting to? I'm going to get to kiloliters. So I put my kiloliters at the top because that's what I'm going to end with. And I'm going to need 2 steps to convert. If you know the milliliter to kiloliter conversion factor, that's great. I find it very difficult. So I always find a middle ground. And what these middle grounds are base units. So base unit examples are, let's see, so you all can write these down. Base units are liters, grams. Those are the 2 ones you'll see a lot, and then there might be some more that we come across. So we have milliliters. We want to get 2 liters since that is our base unit, and we want to cancel out milliliters. So what's on the top has to go on the bottom. And then we need to get from liters to kiloliters. So what's on the top has to go on the bottom. So now let's find those conversion factors. We need a conversion factor from liters to milliliters. If you know that, put it in the chat. Or if you know the kiloliters to liters, put that in the chat. So I know 1 liter has 1,000 milliliters in it, and I know 1 kiloliter has 1,000 liters in it. So we're going to put 580,000 divided by 1,000 divided by 1,000. So put that in your calculator. Once you get an answer, put it in the chat, and we'll see if you're right or not. So after putting that in the calculator, the answer is 0.58 kiloliters. Yes, good job, Shadab. Very good. Okay. So let's see. Okay. Now, this one is a little bit more difficult. This is more applicable. This is using stoichiometry and being able to apply it. If you have any questions, put them in the chat and we'll answer them. And if you're just hopping on, this is Chegg's Stoichiometry Hours. It's nice to meet you. We have different office hours all throughout the week, so I encourage you to join those if you think they would help. But this is just a great way that Chegg is set up for you to learn more about the classes you're taking and get some more content knowledge. So this is a more applicable stoichiometry problem. And it is a dose for a popular medicine is 0.1 milliliters per pound. There are 0.5 milligrams per liter of active ingredient. How many milligrams of active ingredient does a 40-pound toddler get? So this one is a little tricky because it's a word problem, and I think everyone can say that they dislike word problems. They're no fun, and they're normally difficult to understand. So what I would encourage you to do is find the conversion factors within the problem. So the first conversion factor I see is 0.1 milliliters per pound. So I'm going to write 0.1 milliliters per pound. Then let's see what other conversion factors we can find. 0.5 milligrams per liter. And then any more is we can see that there is a 40-pound toddler. So what are we looking for in this problem? What do we want to get in the end? Does anyone know? Okay, we are looking for milligrams. So we need to start with our 0.1 milliliters per pound and get to milligrams. So what we're going to do is start 0.1 milliliters per pound. And we want to get to liters. We see in this conversion factor, we have liters. So we need to get to liters. Does anyone know how we cancel out the milliliters? We've said it a few times, but it is definitely something you want to get engraved in your brain. So we're going to put milliliters at the bottom and liters at the top. And this way we cancel out our milliliters. Does anyone know that conversion from milliliters to liters? In 1 liter, there is 1,000 milliliters. So we're going to put that first part in our calculator. We get 0.1 divided by 1,000. So we're going to get there's 0.0001 liters per pound. Yes, whoever said 1,000 was correct. So we have 0.0001 liters per pound. Now we need to get to milligrams per pound because eventually we're going to want to get to milligrams. How can we get to milligrams per pound? Does anyone have any ideas? Any ideas? So we're going to put 0.0001 liters per pound. And then we're going to use this conversion factor right here, where it is 0.5 milligrams per liter. So the 0.5 milligrams goes on the top, liters on the bottom. And this way we can cancel out our L's. So remember, if it's on the top, it has to be on the bottom to cancel it out. And let's put that in the calculator. So we're going to do 0.0001 times 0.5. Put that in the calculator and tell me what you all get. 3, 2, 1. So we got 0.00005. And we're at 0.0005 milligrams per pound. So our last step is we need to know how many milligrams to give this 40-pound toddler. Any ideas what we should do? I'm going to give y'all a few seconds to type in the chat. How are we going to get from this 0.00005 milligrams per pound to just milligrams? And a hint is whatever's on the bottom has to be on the top to cancel out. And we have one more piece of information that we haven't used yet. Yes, correct. Shadab 0.00005 is correct. So for this last step, we are going to, yes, whoever said multiply is correct. Good job. From TikTok, multiply is correct. So we need to multiply by 40 pounds because what's on the bottom cancels out with what's on the top. So put that in your calculators. Let me know what you all get. Give y'all about 5 seconds, 10 seconds. 3, 2, 1. So we are left with 0.002. Let me rewrite that. That was bad. 0.02 milligrams. That is the final answer. That's how many milligrams of active ingredient the toddler is going to get. So I encourage you, if you have any questions, please send them. That's what I'm here for. I will answer any questions that you have. And if you're new, welcome to the Chegg Office Hours. We are talking about stoichiometry. We have office hours all week long, so I encourage you to join as many as you can. All right. Let's move on to a little bit of using the US system. A lot of chemistry teachers will require you to convert from the metric system to the US system. So this is an important one to get under your belt and to learn. So we are going to start with what we're given. We're given 75.4 centimeters. So I'm going to write that down. And then we need to know, what are we going to? We are going to inches. So I need a conversion factor that's going to get me from centimeters to inches. To get it engraved in your brains again, what's on the top has to be on the bottom. So that's why we put centimeters on the bottom. Okay, so with this conversion factor, most teachers will maybe give it to you. I had to memorize it. But if you're given it, that's great. If you have to memorize it, now's a great time to learn. In 1 inch, there is 2.54 centimeters. So I'm going to give y'all a few seconds to put that in your calculators. Jimmy Haas on TikTok says 29.685. Let's see. And he was right. 29.685 is correct. There's 29.685 inches. And then another important thing with stoichiometry that we haven't gotten to yet is significant figures. Has anyone heard of significant figures? If you have, it's probably not your favorite thing. After taking 6 years of chemistry, it's not my favorite thing either, but we do have to use it. So to use significant figures, we see how many significant figures are in our starting item. How many significant figures are in that starting item? Does anybody know? If you know, type it in the chat. I'm going to give y'all about 10 seconds to tell me. 3, 2, 1. All right. There are 3 sig figs in this number. So there must be 3 sig figs in our answer. So we want to make this have 3 significant figures. 5 is close. There is 5 significant figures in our answer. So you are right about that. But with sig figs, we want to have whatever's in our starting answer and our ending answer. So we need to round this 29.685 inches to 3 sig figs. What would that be? Does anybody know? Can anybody tell me how we would round that to get 3 sig figs? Go 3, 2, 1. That is going to be 29.7 inches. 29.7 inches is our final answer. If you're wondering how I got to that 29.685, I did 75.4 divided by 2.54, and that gave me this number because we multiply the top and we divide the bottom. So we divide the top by the bottom. 29.7 is correct. Good job from TikTok. All right, so we had a question from Extraordinary Explorations on YouTube. What mass of silver oxide is required to produce 25 grams of silver sulfadiazine from the reaction of silver oxide and sulfadiazine? So, first step with this one is a little bit complex. We need an equation of Ag2O. So we need a number here plus however many AgC10H9N4SO2 yields. So it would yield Ag, I think it is going to yield Ag2, Ag3O plus C10H9N4SO2, if I can get that in. So since all of these are 1-to-1, we don't have to balance it since it is going to be that 1-to-1 ratio. So all of these coefficients are going to be 1. What we need to focus on is knowing those molecular masses of this Ag2O and this AgC10H9N4SO2. So of the silver oxide and silver sulfadiazine. So what I always do, you can use a periodic table, but I find a Google search is the best to find these molar masses. But on the periodic table, what you would do, for example, to find a molar mass, let's say we had O2 and we wanted to find the molar mass. We would find the molar mass of one oxygen, which is 16 grams per mole. And we would find the molar mass of another oxygen, which is 16 grams per mole. And we would add these together to get 32 grams per mole. That is our molecular mass. So that's how we find that number. That's how Google finds that number. For this question from Extraordinary Explorations on YouTube, we are going to start with what it gives us. It gives us 25.0 grams of silver sulfadiazine, which is this right here. So it's always nice to label what we have. So 25 grams, and it wants us to go to grams of that mole number that we were talking about earlier. Moles are also important in balancing equations. So what we need to do is, since it's on the top, we're going to put grams on the bottom, moles on the top, and we're going to find that molar mass of silver sulfadiazine. Look it up if you want to, or if you want to solve it, look it up and try to solve it off the periodic table. I'm going to give us about 10 seconds to find that number. About 10 seconds, 5 seconds, 3, 2, 1. Does anyone have that number? Okay, that number is 357.14 grams per mole. So this is how many grams of sulfadiazine, of silver sulfadiazine, is in a mole of silver sulfadiazine. That number that we come up with is our grams to mole ratio. Back to that mole question earlier, this is another example. So then we want to convert to moles of our silver oxide. And this is a 1-to-1 ratio. So 1 mole of, we'll put sulfa to abbreviate, to 1 mole of silver oxide. If this number right here was a 2, we would put 2 for that silver oxide. It really depends on that coefficient. So we have a 1-to-1 ratio. And last, we need the mass of silver oxide. I'm going to start a new line. So we need to put moles of silver oxide on the bottom because that's what's on the top up here. And then we need to put our molar mass of silver oxide. So can you guys find that molar mass of silver oxide? I'm going to give you about 10 seconds to find that molar mass. About 10 seconds, 5 seconds, 4, 3, 2, 1. So it is 231.735 grams per mole of silver oxide. So now you can see the way we've set this up, everything on the top, we can cancel on the bottom, which is what we want because we want to end in this grams of silver oxide. So let's put that all in the calculator. I know that's a lot, but these are some good chemistry questions to get you really great stoichiometry practice. So we start with 25 grams. We divide by 357.14. It's a 1-to-1 ratio here, so we don't have to do anything. So last but not least, we're going to multiply to 231.735 grams. I'm going to give you all about 20 seconds to calculate that. Put that in your calculator. Let me know in the chat what you get. All right. So for the final answer, I got 16.452. 16.452. Now, I saw with our last question that we did, we had a little bit of trouble with significant numbers. So I think this problem is another great example to work on those significant figures. So we're going to walk through it a little bit slower this time. If you have any questions about significant figures, please put it in the chat. Okay, so with significant figures, whatever we start with is what we want to end with. So here we have 25.0. If we have a decimal point, we start from the right and we count left until we hit either no numbers or a 0. So in this case, I count the number of humps where I started at the right. I have 1, 2, 3. So I need 3 sig figs. So I go to my answer and I need 3 sig figs in that answer based on how many I started with. So if I round my answer to 3 sig figs, anyone who knows, tell me what I would round that to. Does anyone know what I would round that to? I'm going to give y'all about 10 seconds to put your answers in the chat. About 10 seconds. 5, 4, 3, 2, 1. Okay, that answer is going to be 16.5 grams. Does anyone still have questions on sig figs? I know it's a tough topic, but it is very important in chemistry. I know a lot of teachers will count off if you don't do sig figs. They might even count your whole answer wrong, even if you did everything right. So if we don't understand sig figs, definitely put that in the chat and we will discuss. Whoever said 16, Shadab, that's really close. We do want that 0.5 though, just to account for the sig figs, but very good job. Very good job. All right. So reminder, just ask any questions you have. We can solve it just like we solved this one here. So any questions you're struggling with, any examples you want to go over, put those questions in the chat or in whatever live stream chat you're on. If you're on TikTok or YouTube, definitely comment those questions so that I can answer them for you. That's what I'm here for, is to help you all better understand stoichiometry, chemistry, sig figs, whatever you need for chemistry. That is what I'm here for. So also, if you're new, welcome to Chegg's live office hours. This is the stoichiometry session, and we have sessions all week. So I encourage you to join as many as you can so that you can get all the help that Chegg is providing for your classes. We're going to go back to an example, but remember to comment those questions. So we have a question, what are equivalent numbers? When I say equivalent numbers, it's from Shadab on YouTube. When I say equivalent numbers, what I mean is whatever is our answer, whatever our number we're given starts with. So in the question that we just solved, we start with 25.0. However many sig figs that number has, we want an equivalent number of sig figs in our answer. So since we started with 3 sig figs that we were given, we want to end with 3 sig figs in our answer, and that's what an equivalent number is when I say an equivalent number. Does that make any more sense? Keep asking those questions, keep asking them. All right, so now we are going to do a little bit more complicated of a conversion with the US system. So we're going to convert 58,492 seconds to days. So we start with what we're given. We're given 58,492 seconds. And we want to get that to days. So there's a few conversions we have to go through before we get to days. I don't know about you guys. I don't know how many seconds are in a day off the top of my head. I wish I did, but I don't. So I like to go by what I know. I know how to get from seconds to minutes. I put seconds on the bottom because remember, I want to cancel out that top number and that bottom number. Then I'm doing minutes to hours. That's another easy one that I can remember. Put it on minutes on the bottom so I can cancel out minutes on the top. And then hours to days. Hours are on the bottom so I can cancel out the hours on the top. Now I'm just going to fill in those conversions. If you know any of them, feel free to comment them. Comment those conversions so that you can check your learning. So I know 1 minute has 60 seconds. I know that 1 hour has 60 minutes, and I know that 1 day has 24 hours. Like I was saying earlier, whatever's on the top, we cancel on minutes and hours. And a trick is whatever the question's asking you to convert to is the only thing you want to have not crossed out at the end. So we are going to multiply the top and divide the bottom. So it's going to be 58,492 seconds. I'm not going to put the seconds there though, because I'm just going to show you all the math. So we're doing 58,492 divided by 60 because it's on the bottom. Then we're going to divide by 60 again because it's on the bottom. Then we're going to divide by 24 because it's on the bottom. So I'm going to give you all about a minute to put that in your calculator. And if you can do it with the correct sig figs, comment that answer. I'm going to give y'all about a minute to do that. And then we will come back and we will see what the answer is. All right, we're going to take about 10 more seconds. 10 more seconds. So put those answers in the chat. 4, 3, 2, 1. So I got 0.67699. Let me know if you got that too. That is with sig figs. And if you know why, comment that so that we know why we got what we did. So this goes back to the equivalent numbers because there's 5 sig figs in what we start with. There's got to be 5 sig figs in what we end with. So those have to be equivalent numbers. 0.68 is close, Shadab. Just remember that you have to use that correct number of significant figures or most teachers will count off. But if your teacher doesn't really care about significant figures, 0.68 is a perfectly good answer. Just so that we apply with all the rules of chemistry, 0.67699 is our answer for this purpose. All right. Now we are going to convert 800 inches to yards. So I'm going to start with what I'm given. I'm given 800 inches. Remember, if you guys have any questions, put those questions in the chat so that I can answer them for you. That's what I'm here for, is to help you better understand stoichiometry and chemistry and how they go together. So I start with 800 inches and I want to get to yards. Again, I can maybe tell you how many inches are in a yard, but we're going to do 2 steps just so that we can really nail how to do that stoichiometry in. So I have inches on the top, I need to put inches on the bottom, and feet on the top. And then I know a conversion from feet to yards. So I put feet on the bottom, yards on the top. That way I can cancel top and bottom, top and bottom. So I know that 1 foot has 12 inches. If you know any of these conversion factors, let me know in the comments. And I know 1 yard has 3 feet. So going off of that, I multiply the top, divide the bottom. So 800 divided by 12 divided by 3. I'm going to give y'all about 30 seconds. Put that in your calculator and get it with correct sig figs. Let me know what you get in the comments. We got about 10 seconds. 10 seconds. 5, 4, 3, 2, 1. Okay, so this one was a little bit of a trick question. Shadab from YouTube says 22.23 yards. If you put that straight into the calculator, that is correct. But remember, we have to do sig figs. Does anyone know how many sig figs our starting number has? It has no decimal points, so I'll give you a hint. We have to start from the left and go right. So comment how many sig figs that number has. 3, 2, 1. So we have 800. We start from the left and we count right till we reach a 0. This number actually only has 1 significant figure. Because there's no decimal point, as soon as we get to the first non-zero number, we stop counting. So our answer should only have 1 significant figure. So to represent this, we can either put 20 or 2 times 10. And that this is scientific notation. If you are unfamiliar, this is scientific notation right here. Yes, 1 is correct, Shadab. And so we can either write 20 because that also only has 1 significant figure, or you can write 2 times 10 to the first. Now, again, if your teacher doesn't care about sig figs, this answer is completely fine. If they do, you need to put one of these answers right here. All right. I see we got a question a few minutes ago from TikTok. Avoid321. What is molality versus molarity? This is a really good question because both of them have to do with D equals M over V. So it is very confusing. How do we tell the difference between these two? So they're actually different formulas. For molarity, it is moles over liters. So if we could say moles of solute over liters of solution. And I abbreviate solutions SOLN. If you're wondering what that means, that's solution. Now, molality is a little bit different in that it is moles of solute over kilograms of solvent. So this is a little bit different. It's kind of weird to see those differences. And if you're just taking basic level chemistry, it might be a little bit confusing. But the way I like to think of this is it's like a liquid versus a solid powder. So we're finding how many moles are in the liquid with molarity, but we're finding how many moles are maybe in a solid powder with molality, because kilogram is a dry ingredient measurement and liters is a wet ingredient measurement. So that's how I tell the difference between those. Liters is liquid, kilograms is dry. So molarity is for liquids, and molality is for solids. Let me know if that answers the question, but that is the difference in molarity and molality. So now we're going to go back to our US conversion questions. If you have any questions, please type those in the chat. I would be more than happy to answer them. I'm here to help you learn about stoichiometry. If you're just now tuning into the live stream, it's so great to have you. We're holding Chegg Office Stoichiometry Hours. They have office hours all week, so I encourage you to join any of them that applies to the classes you have. They're really great to learn more content and get more knowledge for those tough classes. So for this question, we are converting 17 years to hours. So we start with what we're given, and we are given 17 years. And we want to end in hours. So like before, I don't know any conversions from years to hours, so we're going to kind of do what we know. And we know years to days. If you don't, you can either memorize it or you can look it up. But there is 365 days in 1 year. And then we know a conversion from days to hours. So we put days on the bottom and hours on the top. We put days on the bottom because we want to cancel out what's on top. That's the same reason we put years on the bottom, to cancel out what's on top. So last but not least, we need a conversion from our hours to days. Does anyone know that conversion? If you know the conversion from hours to days, please comment that, and we'll check our learning and check our answer, see if we've learned anything new tonight. All right, 3, 2, 1. There is 24 hours in 1 day. So I'm going to give y'all about 30 seconds to put that in your calculator. Check your learning. For this question, we are multiplying everything because everything's on the top. So again, if these numbers are on the top, we multiply them. If they're on the bottom, we divide them. Since all of them are on the top, we're multiplying 17 times 365 times 24. So put that in the chat, whatever you get when you use your calculator to get that. Yes, 25 hours to 1 day is correct. Good job. All right, we've got 10 more seconds. 4, 3, 2, 1. All right, and our answer is 1,000 or 100,000 for 148,000. Oh my goodness, that's a big number. Hard to get off my tongue. 148,920 hours. Now, if you can put that in sig figs, comment what the sig fig answer would be. I'm going to give y'all about 30 seconds for that. Get some water. All right. Got about 10 more seconds. Tell me how to put that in sig figs if you know. Okay, I see a comment from YouTube, Shadab, 15 years. 15 years, close. I think you're getting the 2 sig figs correct. So 2 sig figs is correct. But we're in hours, so it's actually going to be 150,000 hours. So I put this question in here specifically because another thing most people struggle with in stoichiometry is doing what we call scientific notation. I don't know if you've heard of that. If you've heard of scientific notation, let me know. It's definitely hard. Not my favorite thing, but it is very helpful when we get lots of zeros. It's very helpful to organize our answers. So I see comment 15 hours, question mark. 15 hours is close, but we still have that value of 150,000. So 150,000 hours is going to be correct. But does anyone know how to put 150,000 hours into scientific notation? If you know, let me know in the chats of YouTube, TikTok, whatever you're streaming from. Let me know how to put 150,000 hours into scientific notation. All right, we're going to 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, this is a little bit tricky, but what we always start with is imagine there's a decimal point here. Imagine there's a decimal point where there would naturally be a decimal point. And we are going to make little humps till we get to one decimal to the right of the decimal point. We're moving that decimal point to where it's 1 point something or 11 point or 1 point something. We want one decimal point to the left. So we only want one digit over here. So we could do 1.543, 1.28, just kind of depends how many sig figs your number has. So we count the number of humps and we have 1, 2, 3, 4, 5 humps. So that is going to be, I get that 1.5 from there times 10 to the 5th hours. I see 1.5 times 10 to the 15 times 10 to the 4th. 15 times 10 to the 4th is absolutely correct. It is the same answer as 1.5 times 10 to the 5th. All of my teachers just always told me to put only one digit before the decimal. But if your teacher likes 15 times 10 to the 4th, that is the exact same as 1.5 times 10 to the 5th. So either of those would work. I feel like I should pause and give us a little bit more practice with scientific notation. So if that's something that you want, comment and we'll do a little bit more practice on how to do scientific notation. Again, if you have any questions, I would be more than happy to answer those. I would love to answer them for you. I love stoichiometry and I love answering questions about it. So please comment those questions if you have any about stoichiometry. All right, so now we're going to do another example about scientific notation. Let's say we have 7,824,000 and we want to put this number in scientific notation. Does anyone have any ideas how we would do it? So I got a question about the last one. 15 is also two significant figures, isn't it? 15 is. 1.5 is also two sig figs. So either of those work as far as the two sig figs go, but 15 is two sig figs. So good job on that. Now back to the question right here. We have 7,824,000. We want to put that in scientific notation. So to do that, again, we start where our decimal point would be, and we do humps until we get to one number before the decimal. So right here, in that case, our number 7, and then we count those humps. 1, 2, 3, 4, 5, 6. So we take all of our non-zero numbers, we write them with the decimal 7.824, and then we do times 10 to whatever power of those number of little wedges or humps that we counted. So 7.824 times 10 to the 6 would be our answer for that scientific notation. Is that making sense to everyone? If it's making sense and this is helping you learn scientific notation, let me know. And we'll do one more scientific notation problem. We got a comment 7.824 times 10 to the third. 7.824 times 10 to the third would be correct, but not with that decimal point. If you do the decimal point, then you have to put times 10 to the 6th. Times 10 to the 6th. So we are going to move on to converting 30 meters per hour to centimeters per second. I'm going to erase this problem right here that we did earlier so that we have a little bit more room. And we're going to work on this. So this is a little bit more difficult because it has a top value and a bottom value. These always are tricky, but I think once you understand these types of problems, they are some of the easiest that you will find. So we're going to try to really nail in how to solve those problems with two values that you're looking for. So like any other problem, we start with what we're given, and we are given 30 meters per hour. So we're going to start with 30 meters per hour. Now, what I'm trying to get to is centimeters and seconds. Now, the trick with this is, like I said earlier, whatever's on the top has to be on the bottom to cancel out. In the same way, whatever's on the bottom has to be on the top to cancel out. So what I always do is focus on one value to get to my ending answer. So to start, I'm going to focus on this meters and get it to centimeters. So if it's on the top and I want to cancel it out, I have to put it on the bottom. So I have to put meters on the bottom, and I want to get to centimeters, and that's on the top in my final answer. So I'm going to put it on the top in here so that it'll be on the top. Now we can kind of sidetrack all of this right here and use it as one value and then focus on getting our hours to seconds in another. I'm going to use another color just so it's a little bit more organized. So I would put hours on the top because I want to cancel it out on the bottom. So if I want to cancel out the bottom, I have to put it on the top. And then I think of what is a good conversion factor to get me from that hours to seconds. I know hours to minutes, and then I know minutes to seconds. If you're confused on why I put minutes on the top, it's to cancel out that minutes on the bottom. So I'm just going to run through and do a quick check and make sure all my units are going to cancel out to what I want. So I see I have meters up here and meters down here. So I'm crossing out both of those. I see I have minutes down here and minutes up here. So I'm crossing out both of those. I see I have hours down here and hours up here. So I'm crossing out both of those. And I end with what's in my final answer, centimeters over seconds. So I'm good to plug those values in that I need. So if you know any of those conversion factors, let me know in the comments of your YouTube or TikTok, whatever you're watching us from, or Twitch. Let me know. So I know 1 meter has 100 centimeters. I know 1 hour has 60 minutes. And I know 1 minute has 60 seconds. So we're multiplying the top and dividing the bottom. So we do 30 times 100 divided by 60 divided by 60. I'm going to give y'all about 30 seconds to put that in the calculator, get those good sig figs, and let me know what your final answer is. Got about 20 more seconds. All right, 5, 4, 3, 2, 1. As Shadab from YouTube said, 0.8 centimeters per second is correct. 0.8 centimeters per second is our final answer. So good job. If you put that in the calculator, you're going to get 0.83333. Since we have 1 sig fig in our starting answer, we want 1 sig fig in our ending answer. So 0.8 is our answer right here. If you have any questions on how we got that, comment and we can walk through it a little bit closer. I am going to go back to the scientific notation because there is one thing I forgot, and that is doing negative exponents in scientific notation. Sometimes we'll get a really, really small number. So let's say we have 0.0000843. And we want to put that in scientific notation. The students that I TA for, this always confuses them because there's a plus exponent and there's a minus exponent. The way I think of it is a plus exponent is a big number. A minus exponent is a tiny number. And I think that helps like getting those positive adjectives together and those negative adjectives together so that you can kind of realize plus equals big, minus equals tiny. Looking at this number, I know this number is very tiny. It is a very tiny part of whatever it is measuring. So like before, we start with our decimal where it would be. In this instance, it gives us where the decimal place is. We're going to draw our humps till we get one number to the left of the decimal point. And we're going to count them. So 1, 2, 3, 4, 5, 6. Our next step is going to be writing all of the non-zero numbers. So 8.43 times 10. And then, since this is a very tiny number, we use a negative exponent. So it's going to be to the negative 6th power. Does that make sense to everyone? I know that's a little bit different than those really big numbers and those positive exponents, but this is how you do scientific notation with a negative exponent. If you have any more questions, please put that in the chat. Also, we just have a few minutes left of our live stream. So if you have any final questions, I want to be able to answer them all tonight. So please comment them. We also, if you see that QR code in the top left of the screen, that's just to get you a schedule of all the office hours this week. We have so many different TAs and people that can help you with all the classes you have. So if you want that schedule and you want to stay updated with Chegg, scan that QR code in the top left of the screen. We're going to do one final question. Since I saw some questions about moles, I want to do a few easy mole conversions. We'll focus more on this next week too if you want to tune back in. But let's convert 0.00097 moles of silver to molecules of silver. So does anyone have any ideas on how we would do that? If you do, comment on the YouTube or Twitch stream or the TikTok and let me know what we would do. So we always start out with what we're given. In this instance, we're given 0.00097 moles of Ag. And we want to get 2 molecules. I briefly touched on this earlier, and when I said Avogadro's number, in this instance, we will need Avogadro's number. So I encourage you to memorize that. That's definitely going to have to be something you memorize. It's hard at first, but once you get it engraved, you'll have it engraved in your brain forever. So we're going to go from moles of silver to molecules of silver. So I have a question about molar mass. Molar mass is another way to use moles. It's grams per moles. I'll do another quick example after this one about how to use molar mass in a problem. So someone commented multiply by Avogadro's number. You are absolutely correct. That's what we're going to do. We're going to multiply that tiny number of moles by 6.02 times 10 to the 23rd, which is Avogadro's number. Yes, and so the 6.022 times 10 to the 23rd is correct as well. I'm going to give us about 5 seconds to put that in the calculator and let me know what you get. 3, 2, 1. If you got 5.84 times 10 to the 20th, you are absolutely correct. That is the correct answer. 5.84 times 10 to the 20th of molecules of Ag. Okay, real quick with our time left, I want to do a molar mass problem. I'll work more on this next week and try to get some better examples. But let's say that we have 72 grams of oxygen and we want to get 2 moles of oxygen. This is an example of when we would need molar mass. So the molar mass of oxygen is 16.00 grams per mole. You can find this on the periodic table. If you look at the molar mass on the periodic table of oxygen, 16 is what will pop up. Every single element has a different molar mass. So we start with what we're given. We're given 72 grams of oxygen, and we want to go from grams of oxygen to moles of oxygen. Moles is always going to have that 1 coefficient because if you think grams per mole, moles on the bottom, so the number is going to go with grams. So that 16 right here is going to go on the bottom. We're going to divide the bottom, so 72 divided by 16. I'm going to give y'all about 10 seconds to put that in the calculator. Let me know what you get. And remember, we're solving for moles of oxygen. 3, 2, 1. You should have gotten 4.5 moles. Good job, Shadab. 4.5 moles of oxygen is the correct answer. That's just a quick little example of how we use molar mass. Next week, we can kind of connect how to get from grams to molecules. We're about at the end of our time, but again, I really encourage you, use that QR code in the top left so that you can get all the updates about our Chegg office hours and any other information about Chegg you want. Chegg is really here this semester to help you learn and just help you to reach your academic goals at whatever college or high school you're at. There's also a link in the chat if you want to stay updated on the weekly live streams. I will be back next week, so prepare those questions to ask me. I'll come with some too. We'll work more on moles, molar mass, all of that definitely, because that seems to be the area that we're struggling with the most. But I really appreciate you guys joining me today. Don't forget to scan that QR code and come back for more of our sessions for the rest of the week and next week.